Hi student, so now we will continue topic for week 12. Okay, let's get started. Topic 4, self-compaction and consolidation. Our program outcomes, PO1 and PO2. Course outcome, CO1, CO2, and this one is COPO mapping. CO1, PO1, CO2, PO2. Our learning outcomes. At the end of this lecture, students should be able to identify the relative compaction and specification for field compaction. Number 2, determine the field dry density and allowable range of moisture content in the field. Number 3, understand the compaction plants for various types of soils. And the last one, understand the procedure and determine the compaction parameters for quality control using sand replacement method, core cutter method, water immersion method, and also nuclear method. Alright, specification and relative compaction for field compaction. For specification, the degree of compaction on site depend on first is end result specification and number 2 is method of specification. Alright, first, what is the end result specification means? Specification require predictable condition. It is a specified range of working water content and airborne content. Okay, for example, optimum moisture content working range plus minus 2% of the laboratory optimum moisture content. For optimum airborne content tolerance, for example, plus minus 1.5% of the laboratory airborne content. Alright, number 2 is specify range of relative compaction. So we have to determine the relative compaction by using this equation. Relative compaction is equal to achieved dry density over max dry density obtained in laboratory. Achieved dry density means that the achieved dry density that we obtain in the field, right? And then number 3 is achieved minimum is 95% of relative compaction. So means that relative compaction should be greater than 95%, right? Alright guys, look at this. This is a working range of water content. So for example here, this is our compaction curve. We get the optimum moisture content and maximum dry density here at this point. So we have a look at the working range of W or working range of moisture content or water content. So means that for example the optimum moisture content is 11, so working range is plus minus 2, so means that is between 11 plus 2 is 13, 11 minus 2 is 9, so it's between 9 to 13% of moisture content. Right, so similar with the roll max and 95% of roll max, means that relative compaction range acceptable is 95% of roll max density maximum. Alright, this one is for example from this point to this point for 95%, so at this range. Alright, now we refer to the method of specification. A method specification is a site procedure which is identify type of plant, type of soil, the number of passes per layer, the frequency of vibration if applicable. So we will go one by one after this. Alright, for field compaction, we have light equipment and also heavy equipment. So example of light equipment such as rammers, vibrating plate compactors, and vibrating pulse. Example of heavy equipment, for example, smooth wheel rollers, pneumatic rubber tire rollers, ship foot roller, vibratory rollers, and grid rollers. This is all the heavy equipments. Example of light equipment. Rammers is used for compacting small area by providing impact load to the soil. It is light, can be hand or machine operated, suitable to compact cohesive soil and as well as other soil. Okay, for the more info and how the machine is being operated, you may look at this link and watch the YouTube video. Alright, vibrating plate compactors used for compaction of coarse soil with 4 to 8% fines, used for small area. Vibrating plates are also again mounted on machine. The weight vary from 100 to 2 ton with plate area between 0.16 meter square and 1.6 meter square. So you refer to this YouTube link. Alright, vibro tempers. This is used for small area in confined space. Suitable for compaction all types of soil by vibration, set up in a base plate through a spring activated by engine driven reciprocating mechanism. They are usually manually guided and weigh between 50 to 100 kg. So you refer to this link to look at the vibro temper mechanism. Now we go for the heavy equipment. Alright, this is example of field plant. Alright, a smooth wheel roller suitable for finishing operation of field with sandy and clay soil. Not suitable for producing high unit weight of compaction when used on thicker layers. Okay, you may refer to this link how the machine is operated. Alright, so look at this. This is a sheep foot roller, most effective in compacting clay soils, unsuitable for very coarse soil or uniform gravel. Okay, you may look at this link, and this is we call it the sheep foot roller because the roller is just like a sheep foot. Okay. Alright, pneumatic rollers. This one is better compared to the smooth wheel roller. Can be used for sandy or clay soil compaction. Compaction by combination of pressure and kneading action. So it is alright. So this is better, way better than smooth wheel roller. You may look at this picture here, and you refer to this link for further information. Alright, vibratory roller, efficient in compacting granular soil, okay, just sand, okay. Vibrator can be attached to all roller to provide vibratory effect to soil. Okay, this is vibrate, so we have the vibration. Okay, alright, so this is the link that you may refer for this type of roller. Right, grid roller, this one suitable for compacting most coarse grain soil. Provide high contact pressure by little kneading action. Used in subgrade and subbase in road construction. This roller have a cylindrical heavy steel surface consisting network of steel bar forming a grid with a square hole. The weight of this roller can be increased by ballasting with concrete blocks. This is the link that you may refer. Okay, this is grid roller. You can see here this one we have a grid. Alright, guys. This one is special compaction technique. We have vibro flotation, we have dynamic compaction, and also blasting. So what is the difference? Okay, for vibro flotation is we call as the vibro because it's vibration could be powered electrically or hydraulically to straighten the soil. Dynamic compaction, the process involved of dropping a heavy weight repeatedly on the ground and regularly spaced interval. So means that we have different interval, different place. Then we drop the heavy weight at certain height. Okay, at certain design height. And then another compaction is do the blasting. Okay, this one is example of vibro flotation. Okay, you may refer to this link. And this one is dynamic compaction. This is how we do the compaction. Okay, at specific height. And this one is blasting. You may refer to this link. Alright, so for field density measurement, you may have different method. So we have 1, 2, 3, 4, 5 methods. First is sand replacement method, and then core cutter method, emission in water method, nuclear gauge, rubber balloon method. So usually for calculation, we will just focus on the sand replacement and also core cutter method. But you should know what is emission, nuclear, and rubber balloon method. First method, we go for the sand replacement method. You may refer to this link. Okay, this one is suitable for granular soil. So first step is the jar filled with the dry Ottawa sand. Okay, this is the jar. And in the field, a small hole is excavated in the area where the soil is compacted. So first, you have the compacted soil. And then what you do is you excavate small hole with a design or a specific diameter and height. And then the cone with the sand filler jar attached to it and placed over the hole just now, hole at this one. And then sand is allowed to flow out from the jar to fill the hole and cone, right? So this is the step. Right, look at this one. Look at this one. This one is the sand replacement apparatus. Okay. Okay, this one jar, Ottawa sand, and valve. Valve is used to open the apparatus. So means that when you open a valve, the Ottawa sand will fill the hole below. Right, this one is the metal plate and the cone. There will be some calculation that you have to calculate. Okay, some calculation, some equation that you have to refer to calculate the density of soil. Alright, so for example here, this one is example. Sand replacement test was carried out to determine the in situ density of soil. From the following recorded data, determine the value of density required. Alright, so actually this one is not too hard. This is very simple. Alright, so first is mass of soil is removed from hole. So means that here you have hole. Okay, you have hole. You excavate the hole. Okay, this is hole, and then you have okay, you have, so you have a sand here. Okay, you have sand, you have an Ottawa sand here. All right, first initial total mass of sand pouring cylinder is 5724. This one is initial mass, M1. Okay, and final total mass of sand pouring cylinder. So means that what you do is this sand pouring cylinder you place at the top of the remove soil hole here. You place that, and then you open the valve, and then after that the valve you close the valve after the sand is stopped. Fill the remove hole. Okay, fill the hole, and then you will get the final total mass of sand pouring cylinder. So means that this one is M2. So means that you know that there will be you will have the sand is fill the hole, and then have fill the cylinder, fill the cone. Okay, so volume of cone in sand pouring cylinder is 248 centimeter cube. Density of pouring sand is 1560 kg per meter cube. So first is you have to determine the mass of sand run out of cylinder. So means that M1 minus M2. So you will get 2.552 kg. Mass of sand in cone. So alright, so for this one, mass of sand in cone. Alright, so as you know that roll is equal to M over V. So M is equal to roll V. V is 248. Roll sand is 1560. So you will get 0.387. So that one is the mass sand in cone cylinder. Mass of sand required to fill the hole is 2.552 minus 0.387. So you will get this one. So means that this one is the mass in this area. Alright. So volume of hole is equal to Okay, roll is equal to m over v. So v is equal to m over roll. So this one is the m and this one is roll of sand. So you will get the volume is 1.388 times 10 minus 3 meter cube, and bulk density of in situ is, so you get the volume whole. So roll is equal to m over v. So m is m here. Okay, m is mass of soil removed. Okay, so roll is equal to m over v. So you want to determine the bulk density of soil. Okay, so soil that we excavate, so mass over volume. So mass is 2764 times 10 minus 6 over volume of hole, 1.388 times 10 power of minus 3. So you will get 1.99 mg per meter cube. So this is the bulk density of in situ soil. If you want to determine the dry density, you have to find the value of moisture content from the removed soil, from the hole. Alright. So you should know that the value of a mass of soil removed from hole, we get the value from the site, because you remove the hole and then you take the weight of the sample soil, and then for the procedure here, this one we take from the lab, and then the next procedure, mass required to fill the hole, volume of hole, and bulk density, this one we get from the site. Alright, this is all the formula that you may refer, or you just can refer to the calculation. That one is very simple. So roll bulk is equal to m wet over volume, roll dry is equal to m dry over volume, or roll dry is equal to m wet roll dry is equal to roll bulk over 1 plus m. M is moisture content. This is how to determine the roll dry and roll bulk. Alright, student, you may also try this exercise. Okay, this exercise. Okay, so mass of soil removed from hole, mass of soil after oven drying. Okay, so we have the mass of soil from the hole, mass of soil after oven drying. So it means that this one you will get the moisture content. Alright. Initial total mass of sand pouring cylinder, mass of sand after running sand into hole, and then you have density of pouring cylinder, and then you have the mass sand of cone. So you may refer to the previous calculation. Right, so from that calculation you will get the bulk density. Right, so after that you will determine the a dry density by using the moisture content here. This one is dry unit weight. So from the dry density, you will get the dry unit weight by using the equation. Dry unit weight is equal to roll dry, density dry times 9.81. Right, because unit weight is equal to roll times g, gravity, 9.81. Okay, second method to determine the density of soil. Alright, so second method is co-cutter method. You may refer to this link, alright, how the test is conducted. The test is suitable for fine soil free of stones, because the method of co-cutter is very simple, and we just drive the apparatus. Okay, we just drive the apparatus to the ground. Okay, so means that there are no stones required. If there are stones or very hard soil, so it's hard for us to drive the steel cylinder. Okay, so this one is suitable for fine soil free of stones. Okay, so what we do is drive the steel cylinder into the ground. Okay, the cutter is then dug out and the soil trimmed off flush at each end. Since the volume of cutter is known, the bulk density may be determined. At the same time, small sample of soil are taken for moisture content to determine dry density. Okay, so what we do is, okay, first you have the volume. Okay, we have the volume of mole. So you will get the roll is equal to m over v. Okay, so you get the mass of the sample, soil sample, and then we divide with the volume, you will get the bulk density. And then we can calculate the dry density from the moisture content from the sample soil taken. Alright guys, look at this. This is example of core cutter method. When you drive the soil, or when you drive the mold to the soil, and then after that you trim both ends, and you will get the mass of soil, and then you will determine the density, bulk density, and also dry density. This test is quite simple, but it's only suitable for fine soil, which is the fine soil without consists of the any stone or hard soil. Okay, emission in water method. This method is suitable for cohesive or stabilized soil, where the irregular shape in that lump soil has been obtained. Okay, the lump sample is weighed, and after coating with paraffin wax, it will weigh again. Okay, the coated sample is suspended in water from the balance arm, and the submerged mass is recorded. Alright, so mass of paraffin wax is equal to mass of MW. MW is mass of sample with paraffin wax minus mass of sample. So you will get the mass of paraffin wax. If the density of paraffin wax is rho P and the density of water is rho water, so volume of the specimen Vs is equal to M water minus Ng over rho water minus MP over rho P. So the bulk density is equal to Ms over Vs. So we have the Ms here and then Vs here. For nuclear gauge, okay, you refer to this link. Okay, gamma radiation technique to determine in situ and water content. The density meter operated either the drill hole or from the ground surface. The instrument measure the weight of weight soil per unit volume and the weight water present in unit volume of soil. Okay, using the nuclear gauge here. Okay, rubber balloon method. The procedure similar to cell replacement. The test hole is made and the moist weight of soil removed from the hole, and the moisture content are determined. The volume of hole is determined by introducing rubber balloon filled with the water from the calibrated vessel, from which the volume can be read directly. Okay, for rubber balloon method, is this one, as I said, that is similar to the cell replacement, but for cell replacement we determine the mass. For rubber balloon method, we determine the volume of water contained liquid here. So this one is the hole as dark, and then we will fill with the water, and then we will know the volume of the water inside the dark hole. Alright guys, orang-orang yang berhenti belajar akan jadi pemilik masa lalu. Orang yang masih terus belajar akan jadi pemilik masa depan. So mana pilihan kita?